Hello everyone. Today we are going to see examples on this center tap full wave rectifier. We have to see two examples on this center tap full wave rectifier. We will see how the examples are solved, what type of output voltage we get, and how much the PIV rating of the diode is required. But before going towards the example, I like to recall the construction and working of the center tap full wave rectifier in brief. If you not seen this video lecture before about the center tap full wave rectifier, then I will provide its link here in the I button. So you watch it completely, then we solve the examples on the center tap full wave rectifier. This rectifier is we call as a center tap full wave rectifier because this rectifier uses one transformer. That transformer is we call as a center tap transformer, and this rectifier so we call as a center tap full wave rectifier. Okay, the detailed function of this transformer is given that video. So first you watch that video about the full wave rectifier, then you come here to watch this video lecture. Okay, so this center tap transformer having three terminals. From that, the upper terminal and the lower terminals are used to connect the diode. So we use the diode D1 and the diode D2. The diode D1 is connected to the upper terminal A, whereas the diode D2 is connected to the lower terminal B, and the cathodes of both the diodes are connected together, and one load resistor RL is connected in between the common cathode of both the diodes and the common terminal C. Means here the current conduction path towards the C, and this C acts as a common terminal. Okay, so if there is a positive off cycle, during the positive off cycle the diode D1 acts as a closed switch, whereas the diode D2 acts as a open switch. It gets in forward bias condition, and the lower one diode gets in reverse bias condition, and we get the current starts flowing from the terminal A, then it flows through the diode D1, and after that it flows through the load resistor RL towards the terminal C. When there is a negative off cycle, during negative off cycle the polarities gets reverse, and here the diode D1 is in the reverse bias condition, whereas the diode D2 gets in the forward bias condition. So the diode D1 acts as an open switch, whereas the diode D2 acts as a closed switch, and the current starts flowing from the terminal B, then it flows through the diode D2. After that again it flows through the load resistor RL, and it completes its path towards the terminal C. Okay, so once again there is a current through this load resistor RL by conducting the diode D2. When there is a positive off cycle, the diode D1 conducts, and when there is a negative off cycle, the diode D2 conducts. Okay, and we get the output voltage. That output voltage is we call as a DC output voltage, average DC output voltage. We have to see few parameters about the center tap full wave rectifier. First parameter is the VDC, DC voltage, or it is also called as average DC voltage. It is given as twice Vp upon pi. We give the formula for it, and it is twice Vp upon pi. One more formula is there. We discussed a lot on this, and that is PIV rating of the diode. What is that PIV rating? Peak inverse voltage. And for the center tap full wave rectifier, the PIV rating is equals to twice Vp. The ripple frequency or the output frequency, if we consider, then the output frequency is equals to double of the input frequency. We get here the two number of ripples for one cycle of the AC, one ripple during positive half cycle and we get the other one ripple during the negative half cycle. That's why here we get the double number of ripples, two number of ripples when there is a one cycle. So the ripple frequency is double of the input frequency. We see one example on this center tap full wave rectifier. First we read the example, then we take all the data from the example and we find out what to find in this example. Okay, so in a center tap full wave rectifier, in a center tap full wave rectifier, if the transformer secondary voltage is 12-0-12 volt and the load resistance is 500 ohm. Here from this sentence we take the data. What is that data? Here we write down the secondary voltage V secondary. Okay, this is the given data. It is a given data. We write down first the given data. Secondary voltage V secondary is equals to 12 volt dash 0 dash 12 volts. Means the secondary voltage of the transformer is 12-0-12 volts, as the transformer secondary having three terminals, the upper terminal, lower terminal and the center terminal. In between the upper terminal A and the center terminal, we can say common terminal C, we get the voltage. That voltage is the 12 volt. As per the example, here it is equals to 12 volt. And in between the lower terminal B and the common terminal C, there is also the 12 volt. Equal voltage distribution gets because the third terminal, that is the common terminal C, is taken from the center turn. So the winding gets divided in the two equal parts. Okay, so the central terminal voltage is 0 volts because it is a common terminal. Here the secondary voltage we get, that secondary voltage is the 12 volt and the remaining one is the load resistance. One load resistor is connected and that load resistance is RL equals to 500 ohms. It is 500 ohms. This is the given data. The secondary voltage or the transformer rating of the center tap transformer is given by using either 12-0-12 volt or sometimes in example to make you confused they may give its voltage is equals to 24 volts. Means the total voltage in between these two winding is equals to 24 volts. Okay, but in most of the cases they give the value or the rating of the transformer is 12-0-12 volt or they may give the 10-0-10 volt if the 10 volt transformer is there. If there is a other transformer having the value 16 volt, then its rating is given as 16-0-16 volt. Okay, so this is the given data in the example. What to find out? We have to find out the DC output voltage. We read once again the example. Calculate VDC, PIV rating of the diode and the load current. Okay, so here we write down VDC. We have to find out VDC. Then PIV rating of the diode. I am writing in short PIV. And then last one is the load current IL. Okay, so here we have the data and what to find out. We have the given data and what to find out. So here the question comes how we solve this example. So to solve this example, we have to recall the method which we use in the half wave rectifier. Here the first step comes, and that first step is to find out the Vp. What is that Vp? Vp is the peak value of secondary of the transformer. After finding this Vp, we calculate either VDC or we calculate the PIV rating of the diode. VDC is equals to twice Vp upon pi. That formula we seen in our previous lecture. After this, we have to find out the PIV rating of the diode, and once again I will tell you the PIV rating is again equals to twice Vp. Okay, so first it is necessary to find out the peak voltage of secondary of the transformer. The transformer voltage rating is given in the RMS value. So that RMS voltage we require to convert into the peak voltage. So we write down here one sentence, and that sentence is the peak voltage Vp of lower half of secondary winding, or we can write down the upper half. The peak voltage Vp, I am writing here in short, but you write down the complete sentence. The peak voltage Vp of upper half of secondary of transformer equals to peak voltage Vp of lower half of secondary of transformer given by what is the formula? Vp equals to Vrms upon 0.707. The peak voltage of the upper half of secondary of transformer equals to the peak voltage of lower half of secondary of transformer given by Vp equals to Vrms upon 0.707, given by Vp equals to Vrms upon 0.707. Okay, so it is equals to how much? In example, the transformer we use, that transformer is the 12-0-12 volt. So 12 divided by 0.707 equals to 16.97 volts. It is 16.97 volt. So we have now the peak voltage of secondary of transformer. We have to calculate the DC output voltage VDC. We have to calculate DC output voltage VDC, and it is given by VDC equals to twice Vp upon pi. It is twice Vp upon pi. Now twice Vp means 2 multiplied by peak voltage. We have the peak voltage which is calculated as 16.97 volt. Here I forgot to write down 16.97. So this value is 16.97 volt. 16.97 divided by pi means 3.14. If we calculate it, then we get it should be equals to 10.8 volts. It is equals to 10.8 volts. Now the third value we have to calculate, that is PIV rating of diode. PIV rating of diode. What is the formula for PIV rating of the diode? The formula for the PIV rating of the diode is equals to twice Vp, and if we calculate it, then we get it is 2 multiplied by 16.97 equals to 33.54 volts. It is 33.54 volts. What we did? First, we calculated the peak voltage of secondary of the transformer. Then we either calculate the PIV rating of the diode, or directly we can calculate the DC output voltage. Okay, and then if we have to calculate the other values, then we can easily calculate it. Now, what we have to find out? One more thing we have to find out. What is that? We have to find out the load current IL. We have to find out this load current IL. Okay, so the load current IL we have to find out, and for that here we require to use the value of what? We require to use the value of the load resistance RL. So IL, load current, is equals to VDC, the voltage across the load resistor RL, divided by the value of the RL. So VDC is 10.8 divided by 500 ohms divided by 500 ohms. So it is the 500 ohm is there, means the answer is 0. How much? 0.0216 equals to 0.0216 amperes. It is amperes, but we require the value in milliampere. So how many milliampere? It is 21.6 milliamperes. Okay, so this is how we solve the example on this center tap full wave rectifier. We will solve one more example on this. The example is like this. Generally, the examples are asked in this way. The transformer rating is given, and that transformer rating is 12-0-12 volt, or it should be 24-0-24 volts, or it should be 15-0-15 volt, or 18-0-18 volts, because in most of the cases, or you can say the transformer rating is given in this way because there are 3 terminals. So the values are given as 12-0-12 volt. But if the different type of example is asked, then that example is like this. The secondary voltage in a full wave rectifier is 30 volt RMS. The secondary voltage in a full wave rectifier is 30 volt RMS. 30 volt RMS. What it means? It means here the output voltage of this transformer secondary, or the transformer secondary, is the 30 volts using ideal diodes. Now, to make you confused, one word is used, and that word is the ideal. Using ideal diodes, calculate the load voltage. Once again, to make you more confused, load voltage word is used. Load voltage is nothing but the voltage across the load resistance RL. Okay, so calculate the load voltage, load current, PIV rating of the diode when RL equals to 300 ohms. When RL equals to 300 ohms. So first of all, we write down the data. What is that data? The data is the secondary voltage of this full wave rectifier. One more word they miss here to make you more confused, and that is the name of this full wave rectifier. Actually, it is a center tap full wave rectifier, but in most of the cases they call it as a full wave rectifier because the other one full wave rectifier is having the name bridge full wave rectifier. Okay, so here you have to consider it is a center tap full wave rectifier. So data is the secondary voltage V secondary, we can say, equals to 30 volts. Now one may get confused, either this 30 volt is at the upper half winding or the lower half winding. It is the total in between the upper and the lower half winding. Okay, then here one more thing they given, and that thing is the value of the load resistance RL, means RL is equals to 300 ohms. RL is equals to 300 ohms. Okay, now here we have to calculate the load voltage and the load current PIV rating of the diode. The load voltage and the load current we require to calculate. So as per the process, we write down the given data and what to find out. Okay, so here the given data is, I am going to write down here the data, and data is V secondary equals to 30 volt. Then value of load resistor RL is given and it is equals to 300 ohms. Then what to find out? We have to find out three things here. One is the average DC voltage, it is called as the load voltage. Then the load current IL, and then we have to find out the PIV rating of the diodes. Okay, so here the secondary voltage V secondary, we write down here the peak voltage of secondary of the transformer. The peak voltage VP of secondary of transformer is given by VP equals to what? The formula is VP equals to VRMS upon 0.707. But here we have to write down it is a twice VP equals to VRMS upon 0.707. What we have to write down? Why we have to write down this twice VP? Because here this voltage is in between the secondary of the transformer, not in between the upper half or the lower half. This is VP and this is VP. So it is twice VP equals to the VRMS upon 0.707. Okay, so it is 30 divided by 0.707 and it is equals to 42.43 volts. It is 43.43 volts. Okay, now here the question comes, the secondary voltage we got, that secondary voltage is 30 volt. But if in the example they give the 15-0-15, then here instead of directly calculating like this, we calculate. First we mention one sentence here, the upper half winding of the transformer peak voltage equals to the peak voltage of the lower half winding VP equals to VRMS upon 0.707. Here we return the sentence, the peak voltage of secondary of transformer is given by VP equals to twice VP equals to VRMS upon 0.707. So what is the value of VP? VP is equals to how much? 42.43 divided by 2, and it should be how much? 21.22. It is 21.22 volts. Okay, so this is the peak voltage we got. Now we have to calculate the DC output voltage VDC. So VDC is the load voltage, VDC is the average DC voltage, VDC is the output voltage given by VDC equals to twice Vp upon pi, and here it is equals to the twice Vp value we have, and it is 42.43 volt. VDC is 42.43 volts. Okay, so it is twice Vp value 42.43 divided by pi value 3.14 equals to the load voltage. We get that load voltage is 13.49 volts. It is 13.49 volts. Means if we use the transformer having the secondary voltage of the 30 volt, then we get the DC output voltage of 13.49 volts. Okay, then we find out the PIV rating of the diode. The PIV rating of the diode is equals to twice Vp, and already we have the twice Vp value. It is equals to 42.43 volts. After that, we find the load current IL. Okay, so the load current IL is the current flowing through the load resistor RL. Here its formula is IL equals to VDC upon RL. So VDC is 13.49 volts divided by RL. How much? It is 300 ohms. So it should be equals to 44.96 milliamperes. Actual answer we get, it is 0.04496. So if we convert it into the milliamperes, then we get the answer, it is 4496 milliamperes. Okay, now here the third type of example they ask, and instead of taking the third example, I will make a slight change in this same example. In this example, if they return as they given as the transformer primary is connected to AC mains supply, then find FO, ripple frequency. Here sometimes the AC main supply is given, they may not given, then you have to consider the standard AC main supply. Okay, so here we have the standard AC main supply voltage rating is 230 volt and the frequency is 50 Hz. In other countries, the standard rating is 120 volts, 60 Hz. The frequency is the 60 Hz. Okay, so according to the frequency, in example they are not given the frequency, so you must consider what is the frequency of the standard AC mains supply. So here FO, that is ripple frequency or the output frequency, equals to twice Fin equals to 2 multiplied by 50 Hz. Here in our country we get the power supply at our homes having the standard rating of 230 volt, 50 Hz, means the frequency is the 50. So therefore the output frequency is equals to 100 Hz. Okay, so in this way we can solve the examples on this center tap full wave rectifier. The examples are very similar they ask in the examination. If they not use the standard voltage rating as 15-0-15 or 18-0-18 volts, then you consider it is the total voltage, means instead of calculating only Vp, you have to calculate the twice Vp. Okay, after that here the other things you have to calculate. In our next video lecture, we will see the next type of the rectifier, and that rectifier is important for us. That rectifier is the bridge full wave rectifier. Okay.